Hello, welcome to this video. This is question 8 of 20, Coordinate Geometry 1 A level. So in this question, I wish to apologize to those members who have not studied trigonometry, because you need some knowledge of trigonometry. For those who have prior knowledge in trigonometry, it is okay, we can move on. So we have a question here similar to the previous two questions. We are told that P and Q are the lengths of the perpendicular from the origin to the lines. We have this line here, this line, and another line here. So these are two lines, and we have the perpendicular from origin to these two lines. Let me try to illustrate this. These are two lines. One line is here, another line is there. So I have a perpendicular here and another perpendicular. So these perpendicular are coming from origin. This is 90, this is 90. So we have a perpendicular from origin. So from this point to this line, let us call this line 1 and this to be line 2. So the equation, this is my line 1 and this is my line 2. So we know that we are told that P and Q are the length. So this is P. Let me call this to be P and this to be Q, respectively. So my line 2 is here. The equation is given to in form of trigonometry. Then you also have this line also in form of trigonometry. So the idea here is just to know that P will be equal to the modulus of ax plus bx plus c over the square root of a squared plus b squared. Similarly, Q will be found in this form. So we are very lucky that x is 0 and we, I beg your pardon here, this is y. So this is y. So we are very lucky that this is going to be 0. And this is going to be 0 because the point is from origin. So x is 0 and y is equal to 0. Maybe how do we get A and how do we get B? Let me deal with line 1. So line 1, if I'm writing in the form of x plus by plus c equal to 0, then put everything on the left. I'll be having x cos theta minus y sin theta, then minus k cos 2 theta equal to 0. So in this case, a is the coefficient of x and b is the coefficient of y. So a is going to be cos theta and b will be negative sin theta. Then c will be negative k cos 2 theta. So let us substitute. Now I'm not going to waste time substituting x. Okay, let us do it. So p is going to be equal to the modulus a is cos theta times 0, which is 0, plus b is negative sin theta times y, and y is 0. Because this is our x and this is our y. So that is also 0. Then the constant is negative k cos 2 theta. Then all over the square root of a squared plus b squared that is cos squared theta, plus b squared theta, that is negative sin theta squared. 2 will be equal to, now down here we shall get cos squared theta plus sin squared theta, and we know that is 1. Those people with prior knowledge of trigonometry, this is going to be cos squared plus sin squared, which is 1, which is the square root of 1 is 1. Then we shall be left with the magnitude of negative k cos 2 theta, and that p will be equal to k cos 2 theta. So let us call this equation 1. Now let us talk about line 2. Now for line 2, I have q equal to the modulus of ax plus by plus c over the root of a squared plus b squared. Now what is our a in this case? Our a is the coefficient of x, which is sec theta, and our b is the coefficient of y, which is cosec theta. Then our c, I'm going to bring this k on the left hand side, so it is a negative k. So let us substitute here. Q will be equal to, now ax, that is sec theta times x, our x is 0, so that is 0 plus, again this is going to be 0, then minus k divided by the square root of sec squared plus cosec squared. So we shall get q equal to the modulus of negative k. Then down here, sec is the same as 1 over cos, so I'll get 1 over cos squared theta plus 1 over cosec is 1 over sin squared theta, everything under the root. So if I simplify the denominator, I'll get negative k over sin squared plus cos squared. This is going to be the square root of sin squared plus cos squared theta over, now we shall get sin squared theta cos squared theta. And now this is root 1. When you take this sin squared plus cos squared, that is going to be 1. The square root of 1 is 1, so I get negative k over 1 over the root. Now this is sin squared cos squared. This can as well be written as sin 2 theta squared over 2. Sin 2 theta over 2. Remember the 2 is not under the root, so let me first create the space here. We don't need this anymore. Can take away this one also. Well, so how have I come about with this? The other one, we know that sin theta cos theta squared is the same as a half of sine 2 theta. So squared. So I get sine squared over 4, but it is under the root, that's why I'm writing 2. Now, our Q is going to be negative k over 1 divided by, now root of sine squared 2 theta is sine 2 theta, then over 2. I can put 2 up in this case. So our Q is going to be negative k, but don't forget that we are dealing with the modulus. So our Q here is going to be negative k sine 2 theta divided by 2, the modulus. And if we simplify and take the modulus, this negative will die. We get 2q equaling to k sine 2 theta as our second equation. So now at this point, we have q in terms of sine and p in terms of cos. So, and what we need to prove is this p squared plus 4q squared is equal to k squared. So all we need is to eliminate theta from these two equations. We shall connect equation 1 to equation 2 and we come up with the expression needed. So let me create more space here. We no longer need this. Alright, so I have 2q equal to k sine 2 theta as equation 1, and I have p equal to k cos 2 theta as my second equation. So I'm going to square both sides for equation 1. I'll get 4q squared equaling to k squared sine squared 2 theta. This is a technique we normally use when we have sine and cos, because you know sine squared plus cos squared gives us a 1. So similarly, this is now equation 3. I'm going to square this second equation. It will be p squared giving us k squared cos squared 2 theta. So now to add these two equations, I'll be having k squared as a factor. So I get 4q squared if I add the two equations. So 4q squared plus p squared equaling to k squared. Then I'll get sine squared 2 theta plus cos squared 2 theta. So this is to a 1, and you can see that this can be rearranged, and we get p squared plus 4q squared equal to k squared, since this one gives us a 1. So this is the required expression. Thank you for watching. Please subscribe for more videos. So this video, as I said, it requires prior knowledge in trigonometry. So if you have not covered trigonometry, please you can leave this out as we wait for the topic of trigonometry.